Hello guys, welcome back again. My name is Amit and it's good time. So we are finally back again with the final part of C++ STL, STL part 3, that in which we'll be covering up the inbuilt functions in C++ STL that you frequently use. Okay, so we'll cover up the ones that are most important that you actually use a lot while doing DSA or while doing computer programming. There are a lot of functions, but they are not they are not frequently used. So that's why we'll be covering up the most important ones. Okay, so let's start it. Okay. Okay, so first we have the reverse function. So the reverse function is like this, that reverse a dot begin, a dot end. So basically, instead of a dot begin or a dot end, you can give any pointer, starting pointer and the ending pointer. Okay, this can be this basically is an iterator. Okay, iterator basically means you give an address. Okay, this is going to be the starting address and this is going to be the ending address. What this function does is it reverses the contents of the range of that elements. Okay, let's say if if you have given an array or a vector like 1 2 3 4 5. Okay, and you put I'll apply reverse function on it, it will become what? It will become 5 4 3 2 1. It will become 5 4 3 2 1. Okay, so it's very basic, or we'll just try to see if we can implement it. Okay, yep. So yep, let's go to the implementation part. So we have like vector int a. Now I'll just apply the reverse function. So I'll just write the reverse a dot begin comma a dot end. So now if you just try to print this thing, auto it a cout a. So righty. So you will see that the contents of this array have been reversed. Okay. So basically this is a vector. In terms of vector, when we talk about, we'll pass a dot begin or a dot end or a dot begin of whatever range you want to. And in case of arrays, we pass a comma a plus n or a plus whatever you want, right? Let's just print first of all, yeah. So we can see it was 1, 2, 3, 4, 5, 6, and now it's 6, 5, 4, 3, 2, 1. So in this way, basically reverse function works. So I can also do this if instead of a dot begin, I write a dot begin and plus 4. Okay, so what it will do, it will reverse the first four elements. Okay, 0 1 2 3 4, basically up till this index. Okay, let's try to print it again. So you can see the first four elements have been reversed. It becomes 4 3 2 1 and 5 6 remains as it is. So in this way, basically reverse function works. Okay, then we move on to the next function, that is swap. So swap is basically a very simple function. It basically swaps the values within two variables or within two indexes. So you can just implementing it is very easy. Just write swap and a comma b. A basically is the variables what you want, or it can be any like array. Let's say you write a of 0 comma a of 1. So it will swap the values in between these indexes, right, or between any two variables. It's a very simple one, and you can use it. Instead of using three variables to swap values, you can directly use swap function. Then we have rotate function. Rotate function is quite interesting. What rotate function does is it basically moves the the elements of the array by some units. Okay, either to left or to right. Okay, so its implementation is like this: rotate first, mid, and last. So what are this first, mid, and last? First of all, to point out, all these are basically iterators. Remember, all these are what? These are not indexes. These are basically addresses. Okay, addresses like a dot begin or a dot begin plus 4. This basically a dot begin is what? It is an address that points to the first element, right? So remember, all these parameters are not actually the indexes, but they are the addresses of those indexes. Okay, so first, what does first mean? First means the beginning of the range. Okay, so wherever you start. Okay, then we have a mid. Mid represent the new first element. Okay, up till you are going to reverse, and last basically refers to the element that starts after the end of the range. So I'll give you an example. Let's say we have 1 2 3 4 5. We have this array. Okay, we have this vector, and let's say I want to apply the rotate function, and I pass these parameters 1 2 and 4. Okay, so for just for clarity, I have used indexes here, but in general you can write a dot begin plus 1, a dot begin plus 2, and a dot begin plus 4. So what it will do, it will start my my rotate operation from the first index. Okay, this basically means first. So my rotate operation will start from the first index, and it will make second element. So we can see mid is what? 2. And what is mid? Mid basically becomes the new first element of that range. Okay, so here we can see 2 is what? 3. And then we have 4. So 4 is basically which index? 4 is basically this index, right? So we'll basically covering up this much range. Okay, only this 1 2 3. We'll be covering up only this much of numbers, 2 3 and 4. Okay, now what will happen? 3, as we said, this index basically becomes the first element of a range. So what will happen? The rotate operation works in such a way that this element will become what? Will become the first element. So we'll rotate it by like this. So what will happen? We can see 3 and 4 have moved forward, right? 3 moves by 1 unit, 4 moves by 1 unit, and we can see 2 has come at last. So it has rotated. This range has been rotated, right? And 5 remains as it is. So remember, first is what? The beginning of the range. So from where you are going to start. Then we have mid. Mid basically means which element is going to be your what? Is going to be your new first element in that range. So basically, let's say I make 4 as my mid. Okay, then what will happen? This will be like 1 4, and then 2 3. So what will happen, this also will get reversed. Okay, now 4 will become the what, the first element in this range. Okay, and that is how rotate function works. Now I'll just give you an example. Okay, I'll just show you the implementation part. Okay, let's come here. So we have like this. I'll just do this. Okay, just slide rotate, and what, a dot begin, let's say, as I've said, so a of begin plus 1, as I said. Then I have a dot begin plus 2. Then I have a dot begin plus 4. Okay, now let's try to see what happens, and what are the new elements. So yeah, you can see, as I said, what happened. 1, 5, and 6 are as it is wherever they were. You can see 3 has become the new first element of this range. Remember, this 3 has become the first element of this range. 4 has shifted 1 to the left, and 2 has become the last element in this range. In this way, basically, rotate function works. Okay, and this is basically how it rotates. Okay, you can also try out this, basically the left rotation. You can also try out right rotation. Okay, it's not very difficult. You just have to play with the indexes. It's not a it's not a very big task. Okay, and that basically covers up how rotate function works. Now let's go to what, the next function we have, unique. So unique function is also very is quite used. It basically removes the continuous duplicates. Okay, so let's say we have an array like 1 1 5 6 6. You can see, so basically 1 1 are continuous, right? So it removes the continuous duplicates. Remember, it does not remove duplicates from the complete array. It basically removes the continuous duplicates. We can see, if I place one, if I place one more one here, so it will remove this one. It will only take one from here, and this one will remain as it is. Okay, this will not be removed. So that's why it basically removes the continuous duplicates. So if we apply unique function on this, it will become 1 5 6 7 10 9 and 1, right? In this way it works. So then we have replace function. Replace function is also very easy. So what do? Give your starting address, you give your ending address, then you write the old value and the new value, and what will happen, your in your array, wherever the old value is present, it will be replaced by the new value within the range of start and end. Within the range of start and end, the old value will get replaced by the new value. Okay, that covers up the replace function. Then we go to the transform function. Okay, now this is also a very important function. You might be using it a lot of times in C++. So basically, when you want to convert your string to uppercase or lowercase directly, right? The first way is that you go character by character and you convert to lowercase or uppercase. Another form is that you can use transform function. So transform function is very similar to the lambda function in Python. A lot of you might have heard about the lambda function in Python. So transform function is very similar to the lambda function. Okay, what happens is that you give your starting range, your ending range. Okay, and then basically you give this rest basically means where do you want to copy your output to. Okay, let's say I want to copy, let's say I want to apply the operation in this range, and whatever the output of this range is, I want to copy it to some other memory address. Let's say I have one array like this, and this, it has some indexes a1 a2 a3, and I have some b that is also of same size, but it currently does not has any elements. So what I can do first, and in first I can give the starting address of this array a, and in last I can give the ending address of this array a, and in rest I can give the starting address of this array b. So what will happen, whatever values we will get after applying the operation on the elements in this range, the output will be copied in this b. So let's say in the operation, this is the operation basically. So generally it is of two types. One is binary and one is unary. We generally use unary operations using transform function. Like you want to do something on an individual element, right? You want to decrease an element by some value, or you want to increase the some value, or multiply or divide or anything. Okay, so in that, that's called unary operation. So what will happen, let's say I want to decrease each value by some by 5. Okay, so what will happen, this a1 minus 5 will be copied here. Okay, rest will be pointing to starting address of b. So what will happen, it will copy a1 minus 5, it will copy a2 minus 5, and in this way all these values after the computation of the result will be copied to the array b. So this basically the output starting address. Okay, and this is basically the basic structure of transform function. You write a dot begin, a dot end, then a dot begin. This is basically an in place. You can see in for the rest address I have given a dot begin. So what will happen, the values will be replaced in place. Okay, so whatever, let's say I had a as 1 2 3 4 5, and let's say I say ki every element is going to be multiplied by 2. Okay, you can see here we have an operation on c. So every element is multiplied by 2. So what will happen, my a will become 2 4 6 8 10. 2 4 6 8 10. So this basically in place, as we are using the same memory address, as we, on which we were applying the operation to. Okay, a and b are same basically, right? And this type c, you can see here we have written type c. Type basically means whatever type of data you have stored. It can be int, float, double, string, character, anything. Okay, and this basically, a transform function is used, and this will come in very handy when you're trying to convert an element, convert a string to lowercase and uppercase, because in C++ strings are basically considered as an array of characters or a vector of characters. Okay, and that gives you a major advantage in a lot of questions. Okay, we'll be seeing how do we implement it later on. Okay, but first of all, let's cover the other functions too. Okay, and for information, so the reverse function basically has a time complexity of order n. Okay, then swap function has order 1 basically. Okay, then rotate function has order n. Order n basically means, whatever your range is, that will be your time complexity. Unique function again has an order n time complexity. Replace also has an order n time complexity. Okay, and transform also has an order n time complexity. So basically, remember this thing. These functions that are present to in C++ STL, they are also implemented in some form of code in the backend. Okay, the thing is, just in order to prevent the complexity of writing the code and not to make a hodgepodge in the code, so that you're not able to understand and it should be very clear and concise. That's why these functions have been built. The If you go to the backend implementation, they are just as if you would have implemented it from scratch. Okay, they're just same as that. Okay, I mean, in some of the functions, the implementation might be quite fancy. It could be very good. It could be fast. Okay, but at the end, it is all that the scratch code has been, transformed, has been converted into some small function, so that you can directly access to it without actually writing the code from scratch by yourself. Okay, so that's why the time complexity is almost same. Okay, it's not order 1. So a lot of people think that we're using inbuilt function. It is very fast. It is not fast. Okay, transform function also takes order n, so it depends on whatever your range of operation is. Then we have a max element. So max element, like, star max element, and you give the address again. Okay, if for remember this thing, for vector you write a dot begin and a dot whatever, a dot end, or a dot begin in terms of combination of that. In case of array, you write a and a plus 2 or a plus n. That is how you write for applying the operation on array. Remember, applying operation on vector and array is a bit different. Just the syntax is different, just the thing are same. Okay, so this basically returns the maximum element in the range of first and last. Okay, so you can directly get, instead of running a loop and getting the maximum element, you can just write this function and you can get the maximum element in that range. Then you have, this also order n, I will write. Then we have minimum element. So minimum element basically returns the minimum in that range. So again, this is also order n. Instead of writing the loop, you can directly run this function and you can get the minimum element in that range. Okay, then we have accumulate function. So accumulate function basically returns the sum of elements in the range. Okay, so how this happens, you write s and whatever the target variable is, and you write accumulate, and then you just specify the positions. Okay, just the address, a dot, like v dot begin or v dot begin plus 2. Okay, so what this will do, this will basically return the sum of first, two elements. Okay, this will basically tell you the element, the sum of the first three elements basically, because this will be 0, this will be 1, and it will be 2. Okay, so in this way basically write the accumulate function. This tells you the sum of elements in the range. Okay, then we have count function. So count function basically, returns the, you specify the range. First of all, range is very important. Then you specify the value of which you want to count the occurrences of. So this basically tells you the occurrences or the number of times that number or that value has appeared in that range, in the vector or the array. So most of these functions are basically applicable on vectors and array only. Okay, because maps, sets, they already have their specialties, they already have all the functionalities. So most of these functions are basically applicable on arrays and vectors. Okay, then we have a find function. So you might be remembering this function. So find function is also present in strings. Okay, one more thing, all the most of the functions that are applicable on vectors are also applicable on strings. Okay, as I said, in C++, string is seen as a vector of characters. That's why all the functions that you're seeing are also applicable to strings in a similar way. Nothing changes, only that one we have, in first place we have a vector. The second case we have what? We have a string. Rest everything, the syntax even remains same. Okay, then we have find function basically returns the first occurrence of the element in the range. Okay, if you are not able to find that number in the array or the vector, it will return -1. Okay, or else it will return the first occurrence of the element in the range. Okay, then we have is permutation. So basically is permutation tells you if two strings or two arrays or two vectors are permutation of each other. ओके, सो परम्यूटेशन बेसिकली मींस कि जो एलिमेंट पहले वाले एरे में थे वही सेकंड एरे में भी हैं, बट उनका रिलेटिव पोजीशनिंग चेंज हो गया होगा. लेट्स से आई हैव एलिमेंट लाइक 4 6 7 and I have one 6 4 7. So you can see the contents are same, but the relative positioning has been changed. So what will happen if you apply is permutation on these two arrays together? So it will return yes, or you can say it will return 1, telling you that these two these two arrays are basically permutations of each other. No new component, no new value has been introduced. The values are same, and thus the positioning has been changed. Okay, in case of strings, it's called anagrams. Okay, when we are comparing two strings, if they are same, if the characters are same but they have been just position has been changed, that is called anagrams in terms of strings. Okay, but nevertheless you can also say permutation, that does not make any difference. Okay, so one way is that you can apply by range, or you can directly apply by array too. Okay, so you can see here I have written is permutation a dot begin a dot end, and then b dot begin b dot end. So basically you can also do this permutation thing range wise. Okay, let's say you take the first range from the first array, and let's say you take a second range from the second array, and you want to find if the first range is a permutation of the second range. Then too you can also use this operation, you can also use this function is permutation. So this basically tells you if it is a permutation or not. Then we have is sorted function. So instead of seeing running a loop and checking if your array is sorted, this function will directly tell you if it is sorted or not. It's again the same thing, is sorted, and then you basically provide your first and last, okay, your starting address and your ending address. So it's not necessary that you check if the whole array is sorted or not. You can also check if a range of elements within an array are sorted or not. Let's say I have some element like 3, and I have 1 2 4, and then it's say like -1. So I can see this range is sorted. If I apply this operation is sorted within this range, I will get yes, I will get 1. Okay, that means that this range is sorted. But let's say I apply the operation on this range or the complete array, you will get 0, meaning that the complete that range is not sorted, right? And that is how basically a sort function works. Then we have the most important function in the complete C++ STL, the king, the the ace, the everything, the emperor of all the functions. That is the inbuilt sorting function of C++, which is very important. Okay, so again the sort function is very basic. You can write sort a dot begin, and whatever your range you want to sort up to. Okay, you can specify the beginning and the ending part, the last part, wherever you want to do the sorting up to. Okay, and in C++ STL you have the advantage that you can also use custom based sorting. As I said, in priority queues you have a custom based priority function, right? In a similar way, in C++ you can also do custom sorting function. Okay, so instead of writing sorting a dot begin a dot end, what you will do, you will just add one more function, whatever your custom sorting function is, and your array will be sorted according to that custom sorting function. Okay, so this also has an advantage. You have an advantage that instead of just having to sort in ascending or descending order, you can sort in multiple different orders. Okay, that depends whatever your requirement is. Let's say you want to sort some in terms of differences or in terms of some anything. Okay, so you can also write a custom based sorting function. That is a major advantage. Okay, but nevertheless let's talk about how this function works. So in C++, this inbuilt sort function is called as intro sort. The name of this function is intro sort, and it is basically a combination of three sorting algorithms. So backend में तीन sorting algorithm होते हैं जो चल रहे होते हैं. One is the insertion sort, one is the quick sort, and one is the heap sort. Now a lot of people when they see this thing, they are actually confused, because जो sort function होता है ना C++ का, उसका average case time complexity, best case time complexity और worst case time complexity तीनों n log n होते हैं. It is always n log n, and that is why it is quite it's quite nice कि हर बार ये ensure करता है कि आपका time complexity n log n ही रहेगा. But we can see we have two algorithms, quick insertion sort and quick sort, which have their worst case time complexity as n square. ठीक है, अब बहुत लोगों को जिन्होंने पढ़ रखा होगा, they will know that insertion sort takes order n square in the worst case, so does quick sort. Okay, the heap sort is the only one that takes n log n. और आप कहेंगे भैया अगर ऐसा है तो n log n ही यूज क्यों नहीं करते, सीधे heap sort ही क्यों नहीं यूज कर लिया? तो पॉइंट ये है कि कॉम्प्लेक्सिटी भी एक पॉइंट होता है और एक होता है स्पेस यूज. हीप सॉर्ट में एक्चुअली में स्पेस भी जाता है थोड़ा, इंसर्शन सॉर्ट और क्विक सॉर्ट में स्पेस नहीं जाता है. Okay, so basically these things combine work together in some sort of fashion. और वो fashion क्या है कि जब तुम्हारा जो range of elements, let's say you want to sort very less number of elements, let's say 16. So basically this is, I am telling you the exact value. If your n is less than 16, so what will happen, your array will be sorted by using the insertion sort. और let's say कि जब भी तुम्हारा function divide करता है arrays को multiple parts में, जैसे कि quick sort में क्या होता है, एक pivot का use करते हो और according to that pivot you divide your array into 2 or more parts. ओके, सो बेसिकली अगर तुम्हारा जो करंट सब एरे है, फिर जो करंट एरे है उसका साइज 16 या 16 से लेस है, तो तुम्हारा तुरंत इंसर्शन सॉर्ट शुरू हो जाता है उस पर काम करना. लेट्स से अगर तुम्हारा जो डेप्थ है, द डेप्थ ऑफ डिवाइडिंग योर एरे, इट बिकम्स बिगर देन 2 into log n, 2 into log n where n is the current size of the array, then we switch to heap sort. But let's say अगर तुम्हारा जो डेप्थ है वो 2 into log n से कम है और तुम्हारा जो नंबर ऑफ एलिमेंट्स है दैट इज बिगर देन 16, देन वी वर्क ऑन क्विक सॉर्ट. ठीक है, सो बेसिकली अगर मैं जाऊं कि काम कैसे करता है एक साथ में, सो दैट विल बिकम अ बिट कॉम्प्लेक्स, बट द थिंग इज देयर इज अ रेंज ऑफ साइज वेयर दीज फंक्शंस वर्क. कि जैसे ही अगर ये साइज पार होता है तो दिस स्विचेस, Okay, as soon as let's say start. अच्छा, one more thing. When intro sort function starts, it basically always starts with the quick sort function. हमेशा वो quick sort से start करता है, वो heap sort से start नहीं करता है. उसके बाद वो देखता है कि जो current मेरा जो सब प्रॉब्लम है उसका साइज कितना है. अगर वो इतना है कि तुम्हारा डेप्थ 2 into log n के ऊपर हो चुका है, then it switches to heap sort such that कि तुम्हारा टाइम कॉम्प्लेक्सिटी and log n रहे. अगर वो 16 से कम चला गया तो वो insertion sort पे switch कर जाता है. And that is how these all three functions, all these algorithm together work and give you the best optimized time complexity for sorting. ठीक है, ये आपको जानना जरूरी नहीं था, बट आई हैव गिवन यू द ओवरव्यू. Then we have previous permutation function. Okay, this will basically return the previous permutation. Let's say हमारे पास मान लो था 1 2 3 5 4. अगर तुम इसके ऊपर अप्लाई करोगे अपना previous permutation, so this will give you 1 2 3 4 5. So this will basically just give you जो just previous permutation था. Okay, in a similar way we have next permutation function. This basically gives you the next permutation. जैसे कि हमारे पास 1 2 3 4 5 था. So this will become what? This will become 2 1. I hope okay, not 2 1 3 गलत लिख दिया. This will become what is happening. Okay. Yeah. So this will become what? This will become 1 and I think 5 4. Yeah, I think that is the next one. 1 2 3 and 5 4. So this is basically the the next permutation of this array, right? So that is what next permutation tells you. So this basically pretty sums up all the important functions that we generally use in C++ STL जो कि आप यूज करोगे कभी ना कभी. ठीक है, बाकी इतने यूज नहीं होते हैं. And then to sum up all these functions, I have 17th point, that's basically the built-in special bit functions. So these are basically the special functions that work on bit manipulation. Thought वो क्या है, वी हैव बेसिकली फोर सब फंक्शंस. पहला होता है बिल्ट इन पॉप काउंट. ओके, सो बिल्ट इन पॉप काउंट क्या करता है, दैट टेल्स यू द नंबर ऑफ सेट बिट्स इन एक्स. जो कि आपका नंबर एक्स आपने इसमें पास कराया, इट विल टेल यू द नंबर ऑफ नंबर ऑफ सेट बिट्स इन एक्स. सेट का मतलब क्या होता है, जो बिट्स 1 है. ओके, एंड लेट्स से अगर इंटीजर वैल्यूज है तो कोई प्रॉब्लम नहीं है. लेट्स से इफ यू आर डीलिंग विद लॉन्ग लॉन्ग वैल्यूज, देन यहाँ पर पॉप काउंट की जगह पर आप पॉप काउंट एल एल लिख देते हो फॉर लॉन्ग लॉन्ग वैल्यूज, फॉर लॉन्ग लॉन्ग टाइप ऑफ वैल्यूज. Okay, then we have built-in parity function. So built-in parity tells you if the number is odd or even. Very simple, जो कि आपको चेक करने की जरूरत नहीं है, आप जनरली इसको यूज नहीं ही करोगे. ठीक है. Then we have built-in CLZ. So CLZ is basically count leading zeros. Okay, it tells you the number of leading zeros. Leading zeros का मतलब क्या होता है, let's say आपके पास एक नंबर है 1000. ये आपका क्या है, ये this number 8, right? इसके आगे कितने जीरोस हैं, दिस बेसिकली टोल्ड बाय दिस फंक्शन. अब आप ये सोचोगे कि भैया हमें ये कैसे पता लगेगा. ठीक है, ये आगे के जो जीरोस हैं ये डिफाइन कैसे होता है कि कितने आगे पोजीशंस हैं. ओके, सो आई टेल यू, व्हेन यू यूज पॉप काउंट, व्हेन यू यूज CLZ, व्हेन यू यूज CLZ. ठीक है, तो ये बेसिकली जनरली इंटीजर रेंज को कवर करता है. तो इंटीजर जो होता है आपका, इंट जो होता है डेटा टाइप, वो जनरली 31 बिट्स रखता है. जो 32 बिट होती है वो आपके साइन के लिए होती है कि ये नंबर पॉजिटिव है नेगेटिव है. तो जनरली वी नो कि 31 बिट्स होती है हमारे पास, 0 से लेकर 30 तक. ओके, इस तरीके से हमारे पास एक क्या कहते हैं, बिट का एक रिप्रेजेंटेशन होता है, राइट. सो दिस बेसिकली अगर आप CLZ चलाओगे तो दिस विल टेल यू कि अगर आप ये वाला वो यूज कर रहे हो, क्या कहते हैं, रिप्रेजेंटेशन 31 बिट्स का, तो इसके आगे कितने बिट्स होंगे. जैसे कि हमारे पास यहाँ पर आप देख सकते हो, यहाँ पर 4 बिट है, तो 31 माइनस व्हाट 4. सो हम कह सकते हैं दिस विल रिटर्न 27. यहाँ पर हमारा आंसर क्या आएगा, 27. दिस विल रिटर्न यू 27 कि देयर आर 27 लीडिंग जीरोस. बट लेट्स से इंस्टेड ऑफ राइटिंग CLZ, यू राइट CLZLL. दिस विल बेसिकली यूज व्हाट, ये आपका लॉन्ग लॉन्ग फॉर्मेट यूज कर लेगा. लॉन्ग लॉन्ग फॉर्मेट में कितने बिट्स होते हैं, 64 बिट्स होते हैं, जिसमें 64th बिट जो होता है वो रिजर्व होता है प्लस माइनस साइन के लिए. और देन वी हैव 63 बिट्स. ठीक है, अगर आप LL लिखोगे तो ये बेसिकली जो नंबर आपने 8 लिखा था, दिस विल बी रिप्रेजेंटेड इन 64 बिट्स. 64 बिट्स में क्या होगा, यही जो 31 माइनस 4 27 आया है, ये बन जाएगा 63 माइनस 4, विच इज व्हाट, विच इज आई थिंक 59, राइट. तो अगर आप 8 के ऊपर चलाओगे ये फंक्शन, ठीक है, अगर आप बिना एल के चलाओगे तो दिस विल बी 27. अगर एल लगा के चलाओगे तो दिस विल बिकम 59. सो एनी नॉट अ प्रॉब्लम. इट बेसिकली टेल्स यू कि आपका जो करंट बिट है, ठीक है, जो अभी आपका नंबर है, उसके पहले कितने जीरोस आए, कितने लीडिंग जीरोस हैं. सो इन अ वे यू कैन ऑल्सो सी, इट कैन हेल्प यू टू गेट द मोस्ट सिग्निफिकेंट बिट. आप डायरेक्टली देख सकते हो कि भाई 59 जीरोस पहले आए हैं, आपको पता लग गया कि 59 जीरोस आपके पास आए हैं. सो इफ यू जस्ट सब्ट्रैक्ट 63 माइनस 59, यू कैन गेट 4. सो दिस बेसिकली टेल्स यू द योर मोस्ट सिग्निफिकेंट बिट. आप देख सकते हैं यहाँ पर फोर्थ बिट जो है 0 1 2 3, फोर्थ बिट जो है आप देख सकते हो, दैट इज द मोस्ट सिग्निफिकेंट बिट. सो यू कैन ऑल्सो यूज दिस फंक्शन टू get the most significant bit of your number. In a similar way, we have a function built in CTZ. CTZ basically means count trailing zeros. Trailing zeros means कि भाई मतलब जहां पर भी आपका नंबर है उसके एंड में कितने जीरोस हैं. लेट्स से हमारे पास एक नंबर था, ये 8 अगेन था, देखते हैं 8 में वी कैन सी वी हैव 3 ट्रेलिंग जीरोस. ट्रेलिंग का मतलब एंड होता है. सो वी कैन सी ये 3 रिटर्न करेगा. सो आप इस फंक्शन का यूज कर सकते हो टू गेट द लीस्ट सिग्निफिकेंट बिट। आप देख सकते हो कि इस केस में ये 1 है, तो ये लीस्ट सिग्निफिकेंट बिट है। लेट्स से मैं कोई एक और फंक्शन एक और नंबर लेता हूँ। लेट्स से आई हैव 101100। सो व्हाट विल हैपन, अगर आप इस पे सी एल जेड चलाते हो तो सी एल जेड आपको क्या दे देगा, वो डिपेंड करता है आपके रिप्रेजेंटेशन पे। लेट्स से अगर मैं 31 बिट रिप्रेजेंट कर रहा हूँ, यहाँ पर 1 2 3 4 5 6, तो इट विल बिकम व्हाट 31 माइनस 6 विच इज 25। सो इसमें 25 आ जाएगा। तो इससे आप पता लगा सकते हो कि भाई डायरेक्टली कि मेरा जो नंबर है उस पर 25 लीडिंग जीरोस है, इसका मतलब सिक्स बिट इसकी मोस्ट सिग्निफिकेंट बिट होगी। इन अ सिमिलर वे, जब आप सीटीजेड चलाते हो, कंट्रोल ट्रेलिंग जीरोस, तो इट टेल्स यू कि पीछे कितने जीरोस हैं, तो दिस विल रिटर्न यू दिस बिट। ये वाली बिट आपकी रिटर्न हो जाएगी तुरंत। कौन सी वाली बिट? ये वाली बिट। ओके, सो इससे आप पता लगा सकते हो कि आपकी लीस्ट सिग्निफिकेंट बिट कौन सी। सो दैट बेसिकली सम्स अप कि क्या होता है। अच्छा, जितने भी मैंने यहाँ पर फंक्शंस बताए हैं, इसमें इसका टाइम कॉम्प्लेक्सिटी लॉग इन होता है, ठीक है। इसका ऑर्डर 1 होता है, क्योंकि आपको बस चेक करना है आखिरी वाली पैरिटी। आखिरी वाला जो बिट जो है, जीरो वाला बिट, अगर वो 1 है तो इसका मतलब नंबर ऑड होगा, नहीं तो इवन होगा। देन वी हैव काउंट लीडिंग जीरो, दिस इज log n, एंड देन वी हैव काउंट ट्रेलिंग जीरोस, दिस आल्सो हैज log n। ओके, and this covers all the functions that you generally require while implementing questions. Okay, अब आओ जरा थोड़ा implementation में भी चलते हैं, एक एक करके चीजों को कवर करते हैं। बट बिफोर दैट आई हैव टू लुक एट कि कितना है। Okay, it's already 30 minutes. Okay, I'll just try to cover it fast. Okay, so I already have shown you how rotate function works and also how the reverse function works. I'll just show you how swap function works. Okay, I'll just remove this. I'll write swap of what, a of 0 comma a of 1. So this will basically reverse the first, this will basically swap the first two elements. Okay, तो आप देख सकते हो यहाँ पर 2 1 हो गया है, राइट। सो दिस विल बेसिकली स्वैप फंक्शन। देन वी हैव लाइक ट्रांसफॉर्म फंक्शन। ट्रांसफॉर्म फंक्शन में आपको दिखा देता हूँ हाउ दिस वर्क्स। ट्रांसफॉर्म, ठीक है। ओके, सो आई विल इंप्लीमेंट दिस फंक्शन ऑन द होल कंप्लीट एरे। ओके, सब पूरे वेक्टर पे चलाऊंगा। और सिंस आई एम गोइंग टू डू दिस इन प्लेस, मैं चाहता हूँ कि मेरा टारगेट जो मेमोरी एड्रेस है वो भी सेम रहे, तो आई विल राइट अगेन ए डॉट बिगिन, कि इसी पे हो जाए। नाउ व्हाट आई कैन डू, नाउ आई कैन जस्ट स्पेसिफाई int, and I like int c, and then I think I can just do one thing. I can just do c minus 1, or c minus, let's say yeah, let's say c plus 1, c plus 1. Okay, so let's try to run this thing. Okay, what is the problem? Just let me check. Okay, so yeah, so I can write return here. You have to write return here. Okay, so I think this should work now. Expected, yeah. Okay, okay, now let's try to run this thing. So here you can see every element has been increased by 1. So in this way you can try out other things. You can multiply by 2 or anything. That is how see yeah. So this is how basically the transform function works. Okay. Then what do we have? Then I think we have what, max and min element. Yes, I will just cover them up. So you can take what, int mx equal to star max element. You can see I dot begin comma a dot end. Then let's say I have also the minimum element. So star min element. Okay, a dot begin comma a dot end. Let's say I want to get the sum, so int s equal to what, accumulate a dot begin comma a dot end. Okay, so then we can just print them out. uh, what happened? Okay, let me just print them out, mn. Okay, and then we'll just print the sum. Okay, okay, so you also need to specify the initial accumulation value. So what you start with, so आप यहाँ पर देखो, instead of 0 you can also give any initial sum. जैसे कि let's say आपको start करना है, अपना जो summation start करना है, let's say आपकी कोई default value है, so you can also give that value in this parameter. तो मैंने यहाँ पर 0 दिया since I want the sum of all the numbers, और मैं 0 से initially start कर रहा हूँ. Okay, let's try to print them up. So yeah, so maximum element is 6, minimum element is 1, and the sum of all the elements 1 plus 2 plus 3 plus 4 plus 5 plus 6 is what, 6 into 7 by 2, it's 21, right? अब यहाँ पर 0 करके अगर मैं यहाँ पर कुछ मान लो क्या करता हूँ, 5 करता हूँ, so my sum will become 26. ठीक है, क्योंकि मैंने इनिशियल सम जो ले लिया है वो 5 से स्टार्ट किया है, राइट। तो इट विल बिकम 5 प्लस 1 प्लस 2 प्लस 3 प्लस 4 प्लस 5. ठीक है, सो दैट इज हाउ बेसिकली दीज थिंग्स वर्क. ओके, फिर हम जस्ट ट्राई करते हैं परम्यूटेशन वाले फंक्शंस को. ठीक है, एक बार वो भी चेक कर लेते हैं, इस सॉर्टेड और इस परम्यूटेशन वाला. सबसे पहले चेक करेंगे इस सॉर्टेड फंक्शन को. इफ इस what if is sorted, so you can see अब a dot begin आप किसी भी उसमें चला सकते हो, a dot end see out, yes. ओके, नहीं तो कुछ प्रिंट नहीं होगा. So you can see yes, it is sorted, right? अगर मैं थोड़ा आगे पीछे कर दूं numbers को तो this will not print anything. Okay, this is basically how insert function works. Then we have is permutation. Okay, is permutation कैसे काम करता है? उसके लिए मुझे दो array चाहिए होंगे. Vector int b equal to what? Let's say 3, 2 and 1. Okay, this is basically a subset of elements. So what I'll do is permutation. Okay, and a dot begin comma a dot begin plus what? Plus 2, and then we have what? B dot begin comma b dot begin plus 2. Okay, so let's see if this gives yes. So it does not gives anything. Okay, okay, I have to check why. If I choose 3, then 2, this should have worked. ओके, सो इट शुड हैव बीन 3. सो बेसिकली कवरिंग द फर्स्ट 3 एलिमेंट्स. यहाँ पर पहले इसलिए नहीं आया था क्योंकि पहले दो एलिमेंट ले रहा था 1 2 और 3 2. दैट्स व्हाई इट वाज नॉट एबल टू टेल यू विद द परम्यूटेशन. नाउ वी हैव टेकन द फर्स्ट 3 एलिमेंट्स ऑफ दिस एरे ए. ओके, एंड द फर्स्ट 3 एलिमेंट्स ऑफ दिस एरे, राइट? सो वी कैन सी कि ए डॉट की जो है 1 2 3 और 3 2 1 आपस में क्या है? परम्यूटेशन. दैट्स व्हाई वी हैव अ यस. लेट्स से मैं 1 2 और 2 1 करके देखता हूं. सो यहाँ पर अगर मैं 2 कर दूं, यहाँ पर 2 कर दूं और यहाँ पर प्लस 1 कर दूं, ठीक है? सो आई थिंक दिस शुड आल्सो वर्क. सो वी कैन सी कि इसको इसके साथ में हमने चेक किया कि परम्यूटेशन है कि नहीं. तो दैट इज हाउ बेसिकली इट टेल्स यू कि आपका परम्यूटेशन आपस में है कि नहीं. देन वी हैव द नेक्स्ट परम्यूटेशन. सो व्हाट डू वी डू? वी राइट नेक्स्ट परम्यूटेशन एंड ए डॉट बिगिन कॉमा ए डॉट एंड. सो ये भी एक रेंज के ऊपर काम करता है पर जनरली हम पूरे एरे का ही वो लेते हैं. सो फॉर ऑटो आई टी ए साउट आई टी. ओके, सो दिस बेसिकली वर्क्स इन प्लेस. तो जहां पर है वहीं पर काम करेगा. सो यू कैन सी वी कैन सी 1 2 3 4 6 5. ओके, लेट से अब मैं यहाँ पर अगर थोड़ा मैंने घुमा देता हूँ क्योंकि भाई सिंपल सी बात है, प्रीवियस परम्यूटेशन एग्जिस्ट नहीं करता है. 6 5 कर दिया मैंने और यहाँ पर मैं प्रेप परम्यूटेशन कर देता हूँ. प्रेप. ओके, ये क्या हुआ? प्रेप परम्यूटेशन. सो यू विल सी, यू विल गेट योर आंसर एज 1 2 3 4 5 6, राइट? ये प्रीवियस परम्यूटेशन आपका बता रहा है, राइट? अब मैं यूज करता हूँ सॉर्टिंग फंक्शन को. कुछ नहीं करना है, हटाना है, सॉर्ट लिख दिया बस. ठीक है, दिस विल बेसिकली सॉर्ट योर एरे. तो इसको मैं पहले खराब कर देता हूँ. 5 4 देन 1 देन 3 देन 2 देन 6. ओके, you can see we have 1 2 3 4 5 6. Everything is sorted. Okay, so is anything left out? कुछ बचा है? I think everything we have covered. Fight function उतना important है नहीं, count भी उतना important है नहीं. Okay, then I'll just show you the usage of built-in functions. Okay, तो यहाँ पर इसको हम हटा सकते हैं अब. Okay, so yep. So let's say मैं कोई नंबर लेता हूँ int x की जगह int x को लेता हूँ. let's say 5, let's say 8 लेता हूँ. 8. Okay, 8 ले लिया मैंने. Okay, so 8. हाँ, okay. सो लेट्स ट्राई टू प्रिंट आउट सबसे पहले बिल्ट इन पॉप काउंट. बिल्ट इन पॉप काउंट क्या बताता है? इट टेल्स यू द नंबर ऑफ सेट बिट्स. तो अगर आप बाइनरी रिप्रेजेंटेशन में जाओगे, इफ यू गो इनटू द बाइनरी रिप्रेजेंटेशन ऑफ नंबर 8, देन यू विल सी इट्स बेसिकली 1 and 3 times 0, राइट? सो दैट्स व्हाई आपका यहाँ पर जो आंसर आएगा वो क्या आएगा? 1 आएगा क्योंकि इसमें एक ही 1 होता है, राइट? यू कैन सी 1. लेट्स से अगर मैं यहाँ पर 3 कर दूं, 3 का रिप्रेजेंटेशन होता है 1 1. तो यहाँ पर आंसर आएगा 2 बिकॉज वी हैव 2 सेट वंस. कैन से 2. देन वी हैव पैरिटी. आई डोंट थिंक पैरिटी उतना इंपॉर्टेंट है पर मैं फिर भी लिख देता हूँ. Okay, and remember for long values, right? You write built-in pop count LL. Okay, and for any long number you write LL at the end. Okay, बस उतना ही करना होता है. तो पैरिटी लिख देते हैं. तो सिंपल सी बात है, 3 ऑड है तो हमें क्या मिलेगा? हमें ओके पैरिटी बेसिकली या. तो अगर भैया सिंपल सी बात है, अगर ये इवन है तो इवन नहीं है इसलिए 0 है. अगर मैं इसको 2 कर देता हूँ लेट से 2 की जगह मतलब मान लो कोई भी 6 कर दिया मैंने. ओके, सो अगेन इट टर्न 0. ओके, आई थिंक इट इज नॉट वेरी क्लियर कि ये कैसे काम करता है. नेवरदलेस कोई बात नहीं, हम नेक्स्ट पे आते हैं. नेक्स्ट वी हैव व्हाट वी हैव बिल्ट इन व्हाट वी हैव बिल्ट इन CLZ. ओके, नाउ CLZ इज वेरी इंपॉर्टेंट. ओके, जैसे कि मेरे पास 8 था, मैं 8 का एग्जांपल फिर से लेता हूँ. ओके, सो लेट्स ट्राई टू सी इसमें आउटपुट क्या आएगा. सो यू कैन सी वी आर गेटिंग 28, राइट? हमें 28 मिला है. ओके, क्योंकि सिंपल सी बात है 32 माइनस 4 करोगे तो आपको 28 मिलेगा, राइट? उसके बाद लेट से अगर मैं यहीं पर एल एल लगा दूं तो आपको क्या मिलेगा? आपको मिलेगा 64 माइनस 4 कुछ ऐसे मिलेगा, राइट? लेट्स सी क्या आता है. सो यू कैन सी यू आर गेटिंग 60. नंबर वही है पर रिप्रेजेंटेशन डिफरेंट होने की वजह से यहाँ पर जो ये है ना, ये डिफरेंट आ गया. देखो, तो आप इसमें इसमें 32 से माइनस करके पता लगा सकते हो, इसमें आप 64 से माइनस करके पता लगा सकते हो कि आप अभी आपकी कौन सी बिट सेट है. या फिर एग्जैक्ट पता लगाने के लिए यहाँ पर 31 से माइनस कर लो और यहाँ पर 63 से माइनस कर लो. ठीक है। फिर हम आते हैं ट्रेलिंग जीरोस। सो ट्रेलिंग जीरोस कुछ ऐसा खास नहीं है। ट्रेलिंग जीरोस तो भाई सिंपल सी बात है, दोनों ही केस में, लॉन्ग लॉन्ग के केस में और नॉर्मल रेंज में, दोनों में ही सेम वैल्यू देगा। ठीक है, वी हैव 3 एंड लेट्स से इफ आई राइट LL देन 2 द आउटपुट विल बी सेम, क्योंकि 8 का रिप्रेजेंटेशन होता है, वो होता है 1 एंड 3 टाइम्स 0। सो या, so I think this all covers all the functions in C++ STL. Okay, एक बार parity वाला जो function था, built-in parity, I don't think उसका आपको requirement पड़ेगा अभी, पर still I will check out कि उसमें क्या problem था. Okay, but nevertheless I think it's not of use. जो मैंने आपको बताया, built-in counting zeros, leading zeros and pop count, ये तीन function काफी बार काम में आ जाते हैं, and I think that sums up the whole complete STL, C++ STL. I think I've tried to cover everything, all the containers, all the functions, inbuilt functions, and everything that was required. Okay, iterators और functors उतना required होते नहीं हैं because they are quite useless. And I think that brings us to the end of the C++ STL completely. From next video onwards, we'll take up some other topic in data structures and algorithms. Maybe we'll start with some good topic, basically building the basic maths that is required. Okay, so we'll meet again to next time with some another topic. Till then, you can check out the previous parts. Okay, the part 2 and part 1 of the C++ STL. Okay, I think that link would be at the start of the video. Okay, you'll get that link at the start of the video. Okay, so till then, bye bye guys, have a nice day, have a nice year.